I forgot to mention in the last video that you can do this with your calculator just like all the other distributions. So if you go into the stat menu, go to tests, we can find, notice it's the one proportion z-test. So that's why it should say prop in there for proportion. And this is what we want to, calculate this. And actually, sorry, this is a z-test. We don't want a significance test. So I misspoke. We want a z interval. So we want a one prop z interval here. So we want to select this one. And then it says to type in x and confidence level. So here, if you're wondering, well, what is x? X just represents the number of successes. So you don't actually have to do anything. You just type in 170. Super easy. And then you type in your sample size, 2673. Give it our confidence level 0.98, and it will do the rest for us. Calculate. And we have a confidence interval of points between 5.2% and 7.5%. So pretty cool, pretty easy. And, actually it's even simpler math than we've been working on. But, just a little bit of a different application. And one other idea I wanted to mention is, let's say we wanted to calculate a desired margin of error like we said before. Like, let's say we want to find this, answer within 1%. Like, notice this, width here is a little over 2%. Let's say we want to be a little bit more accurate and we want to know what our margin of error need to be, or what would our sample size need to be in order to do that. But basically, if we were to look over here, it says the sample size for a desired margin of error. So if M is our margin of error that we want, and we know our confidence level and everything else, basically also P star, like assuming that we don't know what the population proportion is ahead of time, that's like our guess for what it would be. But if you use a particular sample, kind of like in this case, let's say that this isn't quite as accurate as we want, so we want to get a new data set to be even more accurate. Then we kind of have a guesstimate for, we'll use this as our P star. Our guess is 6.4% or whatever, as what P star would be. But let's do an example to see what if we wanted to improve this to have a margin of error to being under 0.5%. So basically our sample size N would need to be equal to, again, let's keep it with a 98% confidence level. So our Z value here would be the same from before, 2.326. Divided by our margin of error, which would be 0.005. Remember to convert percentages to decimals in all of these formulas. And this would be multiplied by P star times 1 minus P star. And again, let's just use 6.4%. Again, I'll use it as a decimal. And that would make 1 minus P star to be, whoops, sorry, I miswrote this. This would be about 6.4% is our guess based on the sample we just took. And then 1 minus P star would just be the reverse, which would be 0.936. Anyways, let's go ahead and do that math. So 2.326 divided by 0.005 multiplied by 0.064 multiplied by 0.936. And this would leave us with 27.8. That seems wrong. Now I just realized that I forgot to square it, so let's correct that. So if we square it as the formula says, but I just totally forgot, that would leave us with approximately 13,000, let's say, for our sample size. And essentially we would need a lot more people in our survey to improve our margin of error from before. Here it was a little over 1%. And here, if we want to get it to under 0.5%, we're going to need a lot more people.